So this demonstration explains some features of Pascal's triangle. Okay, so Pascal's triangle is here. The entries in it are binomial coefficients. So yeah, if we hover over this square here, we see at the left it says n equals 6, at the bottom it says k equals 0, so it's showing the binomial coefficient n choose k, which is 6 choose 0, which is just equal to 1. And if we step across, we get k equals 1, k equals 2, k equals 3, k equals 4. So here, you know, this triangle here is showing 15. That's 6 choose 4. You see it says n equals 6 on the left, k equals 4 at the bottom. So n choose k is 6 choose 4, which is 16. And as it shows up at the top left, there's a reminder of the formula. 6 choose 4 is 6 factorial divided by 4 factorial times 6 minus 4 factorial. In other words, 6 factorial divided by 4 factorial, 2 factorial. And you work that out, you find it's 15. So we can hover over any of the triangles, any of the little triangles, and we get the value of the corresponding binomial coefficient. If we go all the way over to the left of the triangle, that's where k equals equal to 0. And if we go all the way over to the right-hand side of the triangle, that's where k is equal to n. Right. So here on this row, n equals 6, and the right-hand triangle is where k is also equal to 6. Up here, n and k are both 5. So the next thing we can look at is the symmetry property. Okay, so if we look over here at this entry that we're hovering over, with it's marked kind of light purple color, and sort of reflecting in the middle of the triangle over to the left-hand side, we've got this other one which was marked in green, is now marked in purple. So yeah, the squares, they come in pairs opposite each other, reflected across the middle of the triangle. And the values you see are the same. I mean, here we've got a 6, and then over the other side we've also got a 6. Here we've got a 10, and the other side we've also got a 10, and so on. So what we're saying here, so these are the two different squares, that they're the same. They're on the same row, so they've got the same value of n. But one is n choose k, and the other one is n choose n minus k. So what we're seeing here is that n choose k is the same as n choose n minus k. Well, there's a couple of different ways to see this. The most natural way from the point of view of this course is what's written at the bottom of the screen here. You've got a set of size n, and you let p be the collection of all subsets of size k, so the size of p is n choose k. And we're going to let q be the collection of all subsets of size n minus k, and the number of subsets of size n minus k, in other words, the size of the set q, that's n choose n minus k. And so the claim is that these two sets P and Q have the same size, and that's easy to see because we can have a one-to-one correspondence between them. If we've got a set A of size subset A of size K, then the complementary set n less A, that's going to have size n minus K, and the map that sends A to n the complement of A, that's a bijection between the sets P and Q. And if you've got a bijection between two finite sets, then they must both have the same size. So we see that the size of P is the same as the size of Q, or n choose k is the same as n choose n minus k. Of course, it's also possible to see that from the factorial formula, but from the point of view of this course, the kind of this bijective proof is actually kind of more natural. Now let's look at the other property, kind of key property of Pascal's triangle, is this addition property. If we have any entry here that we're hovering over this 15, which is marked in a kind of purpley color, and then directly above it, slightly to the left and the right, we've got two squares marked in pink. And the point is that the 15 is equal. The 15 in the blue square is equal to the sum of the two things just above and to the left and to the right. 15 is equal to 10 plus 5. And similarly, if we go up here, this 6, that's the sum of 3 plus 3 just above it. This 21 here is the sum of the 6 and the 15 just above it. Okay, so that's a general feature of Pascal's triangle. So we should again try and understand why that is. So as with the symmetry property, in some sense the best proof is a kind of bijective proof, showing that we have two different finite sets. One of them has size 7 choose 2, and the other one has size 6 choose 1 plus 6 choose 2, and there's a bijection between them, so we see that the numbers are the same. But that proof doesn't really fit on this screen, so instead we've given a proof at the bottom using the factorial formula. Okay, so here we are, n choose k, that's n factorial divided by k factorial times n minus k factorial. That's a standard factorial formula for n choose k. Now the n factorial on the top, we can write that as n times n minus 1 factorial. And then this n here, this factor of n here, we can break that down as a k plus an n minus k. So we can have a k times n minus 1 factorial over k factorial times n minus k factorial plus an n minus k times the same thing. Okay. But now if we look at this factor here, you've got a k on the top and a k factorial on the bottom, and that sort of partially cancels out to leave you just a k minus 1 factorial on the bottom. Similarly, over here, we've got an n minus k on the top and an n minus k factorial on the bottom, and so the n minus k cancels against the first term in the n minus k factorial, leaving us with n minus k minus 1 factorial. So now that this thing we've got here, n minus 1 factorial over k minus 1 factorial, n minus k factorial, that's just n minus 1 choose k minus 1. And the term that we've got here, n minus 1 factorial over k factorial, n minus k minus 1 factorial, that's the same as n minus 1 choose k. Okay, so what we've got here, n choose k equals n minus 1 choose k minus 1, n minus 1 choose k plus 1. So we've got a term n choose k somewhere here. Then it's on line number n. It's the sum of two things, two binomial coefficients with an n minus 1. So they're on the previous line, just one line higher up. And one of them has a k minus 1 on the bottom, so that's slightly to the left, and the other one has a k on the bottom, so that's slightly to the right. Okay, so we're seeing that in particular in this example here for the 15, which is 6 choose 2, that's 5 choose 1 plus 5 choose 2.